Okay, now that we know about inverses and matrix algebra, we can actually use this to solve simultaneous equations. And if you struggled with solving simultaneous equations from methods, you will absolutely love this because it's way easier than what we did with substitution and elimination, once you get the hang of it, of course. So essentially what you do is you pull out the numbers into matrices. So what we're going to do is we'll call the matrix A with the coefficients of the x's and y's. We're going to call this matrix X, just x and y, and then we're going to call this other matrix B, 4 and 17. So essentially, the matrix equation we're going to get is AX equals B, but if I do write that out in full, it's going to look like this. 2, 3, 5, 4 times xy equals 4 with 17. And that's always what you do with simultaneous equations. So if you think about multiplying out the left, it's really important to check that this does give you back what you'd expect. So we've got a 2 by 2 and a 2 by 1. So we're expecting to get a 2 by 1. And we know we can times these. So let's see. So 2x plus 3y is what we're going to get in the first slot. And 5x plus 4y is what we get in the second slot. Now on the right, we still have a 2 by 1. It's 4 and 17. So if we directly compare this, what we get is that 2x plus 3y equals 4. And that 5x plus 4y equals 17, which is literally what the equation said before. So this matrix stuff is just another way of rewriting the equations there. Now, if we know that we have these matrices AX equals B, what we know about solving matrix equations is that we just pre-multiply it by A inverse to solve that. So what we're left with is that matrix X equals A inverse times B, which is really fantastic because we can just do that on a calculator or something. Now, as you do these questions, it's good to occasionally practice doing this without a calculator, but I'd recommend you just try a few of these on a calculator while you're getting the hang of it. So we've got 2, 3, 5, and 4 as our matrix. We're also going to have to put in a B matrix, so that's what I'll put here. This matrix is going to be, let's see, dim. It's going to be a 2 by 1, and we'll fill that in. Maybe we won't. Dim 2 by 1, enter. So that B matrix is going to be 4 with 17. Then all we need to do is just figure out what is shift matrix alpha A inverse times shift matrix alpha B. And then if we work that out, it's 5 minus 2. So if you want to interpret this, it's that x equals 5 and y equals minus 2, just like that. Okay. Now, quite often they're going to use a capital X for the matrix, just so you don't get confused. So I might actually swap to a capital X there, just so we're not getting confused between the big X and the lowercase x. Similarly, I'll use this as capital X too. Okay, so that's really good. Now, I've claimed that x is 5 and y is minus 2, but let's check if that works. So if x is 5 and y is minus 2, we'll check the top equation. So that's going to be 10 take 6 does give us 4. And the bottom equation, 25 take 8 does give us 17. So we know that those x and y values are correct. Now, if you're comfortable with that, just stop the video here, but I will quickly show you how to do it on a Texas. If you're not sure about entering matrices there, you would just have to go shift matrix edit, 2 by 2. Then you would go 2, 3, 5, 4. You'd then go shift matrix edit. You go for a 2 by 1 in matrix B. And you would be entering 4 with 17. You'd then be going shift matrix A inverse times shift matrix B. If you do that, you're going to get 5 minus 2, which is exactly what we got before.